Okay, now we've seen then that the matrix 1, 0, 3, 0, 2, 4, 1, 1, 0 breaks into a lower upper decomposition like so. What's the advantage of that? That seemed like a lot of work. Do we get anything out of this? Okay, well, let's take the matrix equation. AX equals B. Here's A, here's our X column vector, here's our B column vector. Okay, well, we can replace A with L times U. So we have our lower triangular matrix multiplied by our upper triangular matrix times X equals B. Any X that solves this system, since this times this equals this, has to solve this system. It's very efficient now to solve the system. Okay, we can just do it by backward substitution and forward substitution, as you'll see. Okay, so what I want to do is, first of all, let's just group this pair of matrices. That means the U times the X. And let's not worry about what X is. Let's just call this Y. So now our equation is Ly equals B. Or 1, 0, 0, 0, 2, 0, 1, 1, negative 5 times. Now, running into a little problem because I'm using X, Y, Z here and I want to use Y here. So I'm going to do something that your book does, and your book is already done. And instead of calling these variables Y and Z, I'm going to call them X2 and X1. Sorry, X2 and X3. And I'll call this one X1. So now my X vector consists of three variables, X1, X2, X3. And there's a certain elegance to that. So now, with that change, I'm safe using Y here. And then I'm going to use, of course, Y1, Y2, Y3. And my B vector is 4, negative 2, 1. Now, what's the solution to this system? Well, you can write out this system. This system, and you shouldn't have to write it out, but right now we're getting used to it. This tells us that Y1 is 4, Y2 is, well, actually 2Y2 is negative 2, and then Y1 plus Y2 minus 5Y3 equals 1. Okay? That's what this matrix stands for. Now we're used to having the matrix and reducing the matrix to this form and back substituting. What we do here is forward substituting. The first row, if we have an upper triangular matrix, is going to have a couple of zeros in it. So we're just going to have Y1 equals, and we see that Y1 equals 4. So our solution is, okay, Y1 equals 4. And now ordinarily the second row could have a number here other than 0. It just happens that we got 0 with this matrix. So this could be some multiple of Y1 plus some other multiple of Y2 equals negative 2. But we would be able to replace the Y1 with the value that we know Y1 has and then solve for Y2. In this case, though, it comes out very easily. Y2 is negative 1. And now we can forward substitute these two values to get, so I'm stuck on my foot here, what's going on? It's not alive, so it's no big deal. It's kind of distracting, excuse me. Okay, now our third equation, of course, has a Y1 and a Y2 and a Y3 term. The Y1 can be substituted here, the Y2 here, and then we can easily get Y3. Okay, well, Y1 is 1, Y2 is negative 1, so Y1 and Y2 are going to add up to negative 3. Add that to 4, add 3 to both sides, we get 4 over here, and we find that plugging these in here and here gives us the solution Y3 equals negative 4/5. if I remember my numbers correctly, and working memory goes when you get older. So double check me on that. But I think, and that's not actually right. Let's see, these add up to 3. Subtract that from 1 and you get negative 2/5. I'm sorry. It's still not right. Should be negative 3/5. How am I not getting negative 3/5? 4 and negative 1 is 3. Negative 3 and 1 is negative 2. 2/5. Oh yeah, okay, y2 is negative 4, negative 3. Never mind. You can verify this. I just had to convince myself. Okay, I'm convinced this is negative 2/5. Okay, well that's good. So we solve the equation Ly equals B, but we need to solve the equation for x. Okay? Well, what does y stand for? Y stands for ux. So now ux is equal to y, and we can take that to the cleaners. Okay, well, not the cleaners, that's not the right analogy, but you get the idea. We can now say that ux equals y, which we declared when we wrote this. We've got y, and we know what u is, so this becomes 1, 0, 3, 0, 1, 2, 0, 0, 1, multiplied by our x1, x2, x3 vector, and that's going to equal our y vector, which is our 4, negative 1, negative 2/5. How do we get this? Well, we can write out this system. This tells us that x3 is negative 2/5. x2 plus 2x3 is negative 1, and x1 plus 3x3 is 4. Okay, well, we back substitute. We've got x3, we substitute that into here, and we get our value of x2. Okay, we substitute it in here, and ordinarily we'd also have an x2, but we got the 0 there, so we don't need it, into here, and we'd be able to solve for x1. Okay, now you should solve that just to be sure. Then I'll solve it, and if I don't mess it up, we'll have a solution. So there's x3. This equation gives us x2 plus 2 times negative 2/5 equals negative 1. Well, that's negative 4/5. We're going to add 4/5 to both sides, so we get x2 equals 1/5. Now, substituting x3 and, if necessary, x2 into the first equation, but we don't need the x2, we get x1 plus 3 times negative 2/5 equals 4. Well, that's negative 6/5. 4 is 20/5, so we're going to have 14/5. And if my arithmetic is correct, then our solution is x, which is equal to x1, x2, x3 column vector, is equal to negative 2/5, 1/5, 14/5. Now we can plug that in, see if multiplying this matrix by this column vector gives us what I say we get here. I'll just check out the first row, and it doesn't work at all, so something's wrong. Among other things, I'm adding 6/5 to both sides instead of subtracting 6/5 here, so that should actually be 34/5. but it doesn't look like that's going to be at all helpful. So something's amiss here. You can see what it is. Write everything out carefully. See if you can correct whatever error I've made here. But this is the process. And what you see from the process is we do the lower upper decomposition. We replace the upper triangular matrix times x with a y vector and solve Ly equals RB. Okay, so here's our y vector. We easily get our solution by forward substitution. There's not a whole lot of calculation involved, which makes it a little embarrassing. I didn't calculate that right, but it happens. Okay. I thought I saw something there, but I didn't. Okay, having gotten our y vector, which is 4, -1, -2/5, our y vector has to equal ux. We're trying to find x, so we write out the equation ux equals y, and we do backward substitution, and we get the column vector for x. Now I'll supplement with a short video. I don't want to do this on video, but I'll figure out what I did wrong and document it, but do it yourself. See if you get it right.